We're in the final stretch, everyone! Episode 14, our second to last video. Today we're going to finish our NIF by setting up collision and doing some final optimizations. Collision is what makes things act like tangible items in Skyrim. It is required or else your object will not be real in the game. Things will fall through it, people will walk through it, and you would not be able to pick it up or interact with it. The AU Wiki has a great article about collisions, and you should give that a read. I also highly recommend watching this video by Kandaran, one of the AU instructors, which I found incredibly helpful as I was making my first clutter collision. Links to these resources are in the description. To add collision for your object, you need a specific collision mesh in the NIF. Collision meshes are most commonly one of three types. Primitives, which are the simplest and least demanding on the computer. Convex shapes, which are slightly more complex and slightly more demanding. And compressed mesh shapes, which are a lot more complex and a lot more demanding. For clutter items, you will generally use primitives or convex shapes. Compressed mesh shapes are typically used for objects that don't move at all, like furniture and buildings and such. Depending on the type of collision mesh, there are different ways of creating it. For compressed mesh shapes, used with furniture for example, you will typically make that mesh yourself in Blender or other 3D software, and then you can combine it with your regular model using either CK Command or Chunk Merge. I'm not going to show you how to do that in this series, but you can see how it's done by watching the Zero to Hero tutorial by AU teacher Dan or another helpful video by instructor Fishy, both linked in the description. For clutter items that get kicked around, we have two options for making our collision, a primitive or a convex shape. Primitives are preferred when possible because they are best for game performance, but primitives are limited to simple shapes such as boxes, spheres, or capsules, which are oval-type shapes. The next best option is to make a convex shape, which is more complex than a primitive but still simple enough to not have a big impact on performance. As the name suggests, it can only make shapes that extend outward. For a concave object like a bowl, you have to be more clever, and a good approach here is to create multiple collision meshes to outline the shape. As shown in the wiki article, this Skyrim wooden bowl is a great example. The collision is made by stacking rectangles, which are primitives, all around the outside, and then linking them into a single collision object by using a ListShape block. The best piece of advice I can give you when it comes to collisions is to extract a vanilla item that is similar to yours and use that as a template or a guide to set up your own item properly. Even if you decide to manually add the blocks in NifSkope, you will want to copy the physics values from an existing item instead of having to guess and play the trial and error minigame in Skyrim. For our donuts, there are several ways we could make the collision mesh. Here are three options I've tried, and they all work. Number 1 has a single collision object nested under the root node, and it uses a ListShape block with multiple separate box shapes contained within. This is probably the most efficient and performance-friendly option. Number 2 has a separate collision object associated with each nitri shape. It's easy enough to do, but be aware that using this approach means that each object will move independently of the other in the game. The third approach is like number 1 in that there's a single collision object and a ListShape block, but it uses a convex shape for the donuts and a primitive for the plate. This is the one we're going to make in this tutorial so that I can show you both types. Open up your NIF from the previous video. I recommend doing collision as the very last step in your NIF because it's trickier to edit. So make sure your model is sized, rotated, and placed exactly where you want in the viewport before you start worrying about collision. We have two shapes in our donut NIF, and the collision mesh needs to account for both. We'll start with the donuts, which can't easily be represented by a single primitive shape. So we're going to make a convex shape for these. First, turn on the Show Collision option by clicking on the bouncing red ball icon up here at the top. Then right-click on the donuts, select Havoc, and then Create Convex Shape. Click Yes at the first pop-up window. In the next pop-up, there are 2 fields you can change. I generally just click OK to use the defaults as a first pass, and that often works just fine. You'll get a confirmation message showing the number of vertices and normals. Click OK, and you'll see the collision mesh shown in red around your model in the viewport. You can click on it, and it will turn yellow to indicate that it has been selected. If the collision mesh created with the default values is a poor fit, you can just delete it and redo. Simply right-click on the BHK Convex Vertices shape and select Block, Remove Branch, and Yes at the confirmation window. Then try again by right-clicking on the donuts, select Havoc, Create Convex Shape, Yes, and tweak the top value in this pop-up. Reducing the value at the top will create a shape with more vertices, so you can bump this down a bit if you need a better fit. Just remember that more vertices means more pull on the system, so do try to keep your vertex count down for the collision mesh. Collision shapes do not have to fit your model perfectly, just enough to make sense in the game. And note that if you really struggle to make this collision mesh, it may mean that your model is not scaled to Skyrim size. So you'll want to check and fix that if needed. Now you'll see in our block list here that the donut collision has been added under the Donuts node. We don't want this for our approach. Instead, we want a single collision object under the root node that will apply to the entire model, not each shape individually. We can easily change this by selecting the root node, and then in the Block Details pane, double-click in the Collision Object field and enter the number associated with the BHK Collision Object block. For me, that is the number 12. And here you can see it listed now under the root BS Fade node. We don't want it under the donuts, so select the Donuts node, and in the Block Details, double-click Collision Object and backspace to remove what's listed. Then hit Enter. You should now see the BHK Collision Object listed only as a child of the root node. There's one more step here. If you expand the BHK Collision Object, you will see that its target is still set to the Donuts node. We need this to point to the root node so it will apply to the entire model. So double-click in that target field and enter 0 for the root node. And there we go. The structure should look like this. Now there's a lot more we're going to need to fix up, but let's get the primitive shape for the plate added first. We got off easy with the donuts because Create Convex Shape is essentially a one-click function. But for the plate, we're going to use a primitive shape, and there isn't an automatic function for adding a well-fit primitive right here in NifSkope Dev 7. We could copy and paste a collision block from another NIF or another shape in the same NIF and edit it, or we can create the primitive shape from scratch. We're going to do the latter so you can see how this works. Right-click anywhere here in the block list and go to Block Insert. Click Yes at the pop-up, and then select Havoc and BHK Box Shape. Don't panic if your block list collapses and looks strange. This is going to happen several times during the process, but we will fix the structure as we go along. Expand the root node again, and you can see that everything is still there. But the box shape we added for the plate is not where it belongs. It needs to be nested in the collision object. This is not quite as simple as what we did before, because if you click through the collision blocks, you can see that this particular setup only allows us to point to a single target or shape. In our case, however, we have two shapes, one for the donuts and one for the plate. So we need to tweak this setup to accommodate that. In order to have multiple collision shapes in a single collision block, we need to use a ListShapes node. Right-click anywhere in the upper pane and go to Block, Insert, and click Yes at the pop-up. Then select Havoc and BHK List Shape. Once again, your list will probably collapse and the new node just gets inserted at the top. We can easily put these two new blocks where they need to be by editing the references in the existing blocks. Expand the BS Fade node again, then expand the BHK Collision Object block and select the BHK Rigid Body line. In Block Details, double-click the Shape field and enter the number associated with the new ListShape node that we just added. This is number 0 for me. Things will rearrange themselves and they'll be wrong for a moment, so let's keep going. Expand the BHK Rigid Body block and select the BHK ListShape block that sits underneath it. In Block Details, find the field that says Num Sub Shapes. Double-click and enter the number 2 since we have two collision meshes, one for the donuts and one for the plate. Then click the little green up and down arrow icon in the line just below it for Sub-Shapes. This is a refresh function, so after clicking that, you should see the Sub-Shapes is now an expandable block. Click the little white arrow to open it up. In each of the Sub-Shape lines, double-click and type in the number associated with each collision mesh. For me, this is number 16 for the Convex Vertices shape, which is for our donuts, and the number 1 for the BHK box shape, which is for our plate. Be sure that you enter the numbers associated with the shapes in your own NIF. As you type them in and hit enter, you should see the changes take place in both the block list and probably on the model in the viewport. Don't worry that you can't see the plate collision yet. We are getting to that. Expand the BHK ListShape block in the top pane. Note that the two shapes are now nested under it, like this. Alright, let's go ahead and fix our invisible plate collision. Select the BHK box shape. Note that in the block details, the dimensions are all set to 0, and this is why we don't see anything. Double-click in this line and set the X, Y, Z axes to appropriate values to create a box around your plate. Mine looked good when I set X to 0.21, Y to 0.21, and Z to 0.01. Great, so we now have a box that is roughly the size of our plate. But it doesn't fit over the plate quite right. And we can't make that better by changing the dimensions for Z, since all that does is make the box taller in both directions. But we can fix this by adding yet another block. If we only had one collision shape, we could simply edit the BHK rigid body block. By converting it to a rigid body T block, like so, we could then use the translation fields in the block details to move the collision mesh around. But you'll see here that this moves the entire block. And this is not what we want for our model, because that'll mess up the donut collision mesh. So I'm just going to set this back to 0, and then I'll convert it back to a regular rigid body node. And I'll note here that for a regular rigid body node, the one without the T in the name, the translation values down here are inactivated, and so they don't do anything. Alright, so we want to move just the plate collision mesh. How can we do that? Well, we need another block, a Transform Shape block. So right-click up here in the top pane, go to Block, Insert, and click Yes at the pop-up. Then select Havoc and BHK Convex Transform Shape. Of course, this messes up our list again, so expand the BS Fade node, expand the BHK Collision Object, then the BHK Rigid Body, and select the BHK List Shape. We need to set this new transform block to be one of the two collision shape blocks, and then we'll make our box shape into a child of the transform block. To do this, double-click on the Sub-Shape field in the block details that corresponds to the BHK box shape, and change this to the number associated with the new transform shape block that we just added. This is 0 for me. This replaces the box shape, which will now pop out and be where it doesn't belong, and this is fine. We just have to tell NifSkope where we want it to go in the new structure. Expand the BHK List Shape block and select the new BHK Convex Transform Shape line. In its block details, double-click on the Shape field and enter the reference number for the plate BHK box shape. This is number 2 for me. It should now appear nested appropriately, like this. We can use this transform shape block to change the position, rotation, and scale of its child shape, which is our plate collision mesh. All we need to do is nudge our box up along the Z-axis just a bit. So right-click on the transform line in block details, then select Transform, Edit, and Yes at the pop-up. This looks similar to the transform box we used to rotate our donut model in the last video, and it works the same, except that it's changing our collision mesh. Edit the Z-axis value to raise the box shape so that it fits better around the plate. For me, a value of 0.012 worked pretty well. If you have trouble editing the numbers, just highlight the number at the decimal place you want to change and type in a new value. You should see your box collision mesh move here in the viewport as you play with these values. Once you're happy with how it looks, hit Accept. And that's our collision shapes done. But we aren't finished yet. We have our shapes, and now we need to define the physics parameters of this object to control how it actually behaves in Skyrim when it gets dropped or kicked around. There's a lot of fields that we have to edit, but don't panic. We're going to start at the top and work our way down. And we're going to do a lot of copying and pasting. This is where I recommend pulling up an existing vanilla Skyrim object that is similar to yours and using its values as a starting place. First, let's save our NIF. You can just save to replace the original, or save as with a new name if you prefer. Now we need to have NifSkope fix the order of these collision blocks because we made a bit of a mess of them. And if the numbers are not in the correct order here for your collision, it will crash the game. Luckily, this is an easy fix. Just go to Spells, Sanitize, and Reorder Blocks. Click Yes at the pop-up, and voila! Crash avoided. Okay, expand the root node and all of the blocks underneath, and make sure your NIF is structured like this. Save the NIF again. Now let's pull up a reference item. The easiest way to get the right physics values for your object's collision is to simply copy and paste them from another NIF. I'm going to use the Pi NIF to set up our initial values. These can always be tweaked later after we see how it works in the game. Go to File, New Window, and arrange this second window next to your donut NIF. In the new window, go to File, Browse Archive. Navigate to your SSE game folder, then the Data folder, and find the Skyrim Meshes 0 BSA. Select it and hit Open. In the blank line at the top, type Pi01 to filter for that item. Then click or double-click on it, and you should see the Pi model in the viewport. If you click on the Pi in the viewport, then the Pi block list should load up. Now this becomes just a copy-paste exercise. We will select a line in the Pi NIF, Control-C to copy it, then select that same line in the donut NIF, and Control-V to paste. Before we edit the collision values, let's talk about this line right here. The pie has a BSInvMarker, which lets you change how the object appears in your character's inventory window versus how it sits on the ground. This block is not required, but it's useful if you want the item to be rotated to a certain viewing angle or scaled to be bigger or smaller in the inventory window. Let's copy it over to our donuts just so we can talk a bit more about how it works. Select the BSInvMarker line in the pie NIF, Ctrl-C to copy, then select the root node in the donut NIF and Ctrl-V to paste. In the block details, you can edit the values. The rotation units here are in radians times 1000, and you can use this handy chart to help you figure out what value to use. I'll put a link to this in the description. For our donuts, I'm just going to set all these to 0 by double-clicking on each line and changing it. And then I'm going to change the zoom to 0.8 so that our donuts will appear almost their regular size in the inventory window. Next up is the BSXFlags. You must have this block, unless the object is a worn item like armor or clothing. If the BSXFlags block is missing, or if the flags are wrong, your object will be invisible in the inventory window or it will not work correctly when placed in the world. We have this block in our donuts, which is good, but there are no flags marked by default. So we need to copy them over. Select the BSXFlags block in the pie NIF, and then select the integer data line in the block details. Ctrl-C to copy it. Select the BSXFlags block in the donut NIF, and then select the integer data line in block details, and Ctrl-V to paste. You can also click the little flag icon to open this up and see which flags are ticked. Pay attention to these flags as they will affect how your object behaves. Your best bet here is to find an existing item that is similar to yours and use the same flags. Okay, now select the BHK collision object block for the pie and copy the flags line down in the block details section. Find that same line in the donut NIF and paste it there. Next, expand the BHK collision object block for the pie and select the BHK rigid body block. Here's where the real work begins. In block details, copy and paste all of the lines highlighted here from the pie to those same lines in the donut NIF. It is essentially every single line except for the top one, which must point to the specific collision mesh in each NIF. And you can skip the unused lines and the translation, rotation, and center lines, which will be unique and specific to the collision mesh within each NIF. I'm not going to read all of these out as I do it, so just be sure you copy them all except the ones I've noted. And be sure to expand the Havoc filter copy and inertia tensor lines and copy all of the lines that are nested underneath both of those. If you want to know what all of this stuff is, have a look at the wiki page that I've linked in the description. One thing to call your attention to here is the center of mass. An object's center of mass is indicated by the little XYZ widget shown on the model in the viewport, and you can change it here in this line called center. As described in the wiki, when Z is positive, the object will flip upside down when it's picked up, and when Z is negative, the object will right itself. And note that the center of mass does not control where the item is held when it's picked up, because that is determined by the origin point instead. One other quick point here, mass is supposedly a kilogram value, but it's not accurate for Skyrim. So again, I suggest copying the value from an existing item that is similar to yours. Alright, when you have finished copying all these lines, we are done with the pie. There are just a few more bits that we need to add to our donut NIF before we are finished. Expand the BHK rigid body block and select the BHK ListShape. In block details, we need to give this a material. For a list shape, it doesn't really matter what we put here because it will be superseded by the material we're going to list in each separate shape underneath. But we really shouldn't leave this at 0. To see the material options, double-click in this line and scroll to the right until you see the little drop-down arrow. The material you choose here will control what sound it makes when the item is dropped, whether or not arrows will stick in it or bounce off, how it will behave in water, and so on. Foods tend to use the Sky Have Matte cloth material, so let's choose that. Now click on the first collision shape in the list. For me, it's the convex shape for the donuts. In the block details, change the material here as well. None of these can be 0, but this is the one that really matters, and whatever I pick here is going to apply to the donut part of this model. I'm going to use Sky Have Matte cloth again. The radius number controls the depth of an invisible buffer space around the collision mesh. If your object floats above other surfaces, you can reduce the radius to help. Very small objects will need a very small radius, like 0.001 or even less. 0.05 is the default value, and it may work fine or it may need to be adjusted. For our donuts, we need to go ahead and set this radius down to 0.01, because otherwise, the buffer around the donuts will extend outside the buffer of the plate, and strange things will happen. As you can see here, where arrows are sticking into this model where they shouldn't, when we leave the donut radius at 0.05. Okay, now select the Transform Shape block. This is the one for our plate collision. Whatever values we put into the material and radius fields here will need to be copied into the box shape block itself as well. I'm going to go with Sky Have Matte Material Ceramic Medium for the material. And then I'll set the radius to 0.01. Select the BHK box shape and put those same values in. Material is ceramic medium, and the radius value is 0.01. And now we're done setting up the collision. Save the NIF, and then there's just a couple of things left to finalize it. We aren't going to do anything more to our BSLightingShaderProperty block in this NIF, but I want to mention that there are quite a few options in there that are important for how your NIF looks and behaves. Going over that in detail is beyond the scope of this series, but you can have a look at this video for a few tips. I'm also going to take a moment to call your attention to one particular thing since this is a pretty common mistake. For armor or clothing, you need to have the skinned flag here in ShaderFlags 1 in LE NIFs. And you need to have the skinned flag in ShaderFlags 1 and in the vertex description flags in SSE NIFs. However, for ground models for those items, and any other static item that sits in the world, we should not have skinned flags anywhere, or else the object will be invisible. Okay, once you're done with the NIF, the very last thing you should always do is to clean and optimize the file. Let's walk through that now. First, go to Spells, Sanitize, and Reorder Blocks. Hit Yes at the confirmation window. Even if you already did this earlier, do it again just to be sure. Expand the root node, and then expand the blocks to check and make sure everything looks good. If you see any blocks you want to rename, just go to the Header tab, expand the Strings line, and you can double-click on the strings here to edit them. I'm going to change Torus.008 to Donuts Mesh, and Circle.002 to Plate Mesh. To complete the optimization, I recommend that you always go to Spells, Optimize, and Remove Bogus Nodes, and then Spells, Optimize, Remove Unused Strings. If the lighting looks funny on your model, especially if it seems darker than you expected, you may need to reface the normals and/or update tangent space. To do that, right-click on the model, select Mesh, Face Normals, and Yes at the pop-up. Then repeat and select Mesh, Update Tangent Space. If you had any bad normals, you should be able to see a difference in the lighting on the model in the viewport after doing those 2 steps. There are other options in here that you can try, such as smoothing normals, but I advise that you always save your NIF before you do that in case you don't like the results. Okay, after all that, we're finally done with the NIF. Save it one last time and then celebrate. Here's our completed donut NIF ready to put into the game. We will do that next time, and I hope you're as excited as I am to see the culmination of all of our hard work. Thanks for watching, and I'll see you soon for the last episode. Bye!